Okay, continuing with Unit 10, dealing with circles. You've already completed Level 1, which I've included here also. Level 2 is going to get a little bit more into calculations of measurements dealing with circles. We're going to start out just talking a little bit about pi. In 2b, you'll do area and circumference, which I believe will be mostly review for you. In 2c, you'll talk about two different things, which are parts of circles. One is called arc length, the other one is called a sector. And then when we get to 2d, we'll look at all four of those different things and their formulas and how they can be applied to different things. Also included in this booklet, I've included Level 3, which is basically how to deal with the equation of a circle and how that looks as a graph. So let's get started into 2a. 2a has the main question, what is pi? All right, so pi is a Greek symbol that represents the ratio. If you remember, a ratio is like a fraction, is comparing two things. And it is comparing, in this case, the ratio of the circumference of any circle to the diameter of that circle. So regardless of the circle's size, doesn't matter if it's a little circle or a big circle, the ratio from circumference to the diameter is always going to equal pi. In decimal form, the value of pi, normally we would say 3.14. That is approximate, that is rounded off. But in reality, pi is an irrational number. Okay, so if you think back to your algebra, irrational numbers are numbers that do not repeat as a fraction. Like if I divided it out and I look at the decimal form, excuse me, for example, if I have the ratio 1 to 4, okay, and I divide 1 divided by 4, that comes out to be 0.25. Okay, this is the decimal form of this ratio. So with pi, when I'm comparing the circumference and the diameter, and I divide that out, the decimal form does not repeat, and it does not end. Do not repeat. How about does not? And does not end. Or terminate is another way that we sometimes say that. So in other words, pi goes on and on and on and on, and it never repeats a standard or a common number. So here is just a little example of some of the digits of pi. It's approximately equal to, and you can read it here yourself, obviously a dot, dot, dot means it keeps on going. The digits go on and there's no pattern to it. Okay. So pi, and probably even more by this point, has been calculated to over 60 trillion decimal places. 60 trillion. That's a lot, to say it precisely. And still, there is no pattern to the digits. There's been lots of investigations and lots of looking at the patterns or trying to find the patterns with the digits, but it's amazing with this many digits in those many decimal places how there is really no pattern that they can find. Let's quick go to page 2 here. By definition, this is kind of a review here. The definition of pi is the circumference divided by the diameter of the circle. So if you see over here on this picture, we've got the circumference, which is the distance around the circle, and we've got the diameter, which is the distance across the circle. When I take those, the circumference divided by the diameter, that is represented as pi, which approximately is 3.14159. Okay, it doesn't matter how small or how big the diameter is, the ratio is always going to be about a little bit more than 3 of these to equal the circumference. Now, when we're calculating, which is what we're going to be doing a lot in this level, when we calculate, we have a difference between what we call the exact answer and a rounded answer. As said before, pi is an irrational number. So it keeps on going and going and going, and it's never going to be exact unless I leave it with the symbol pi. So if I had this multiplication here, 5 times 5 times pi, and I wanted an exact answer, I would multiply the two numbers and then multiply that times pi. Now, I'm not actually going to multiply it out. I'm just going to leave it like that. That is the most exact answer that multiplication could be. Same thing down here. I take 2 times 12.4 times pi. I actually just multiply these numbers here, 24.8, and I put the pi on the end, and that would be my exact answer. This space in between here actually means multiplication. Okay. Now, if I want a rounded answer, which most of our work will be, I have two options. I'm going to take 5 times 5 times, I'm going to take the approximation for that, so I can go 5 times 5 times 3.14. Okay, and I can just type that in like that, and when I do, I'm going to get 78.5. Now, sometimes you'll round to the nearest tenth, sometimes to the nearest hundredth. I don't really care unless the directions tell you specifically what to do. So make sure you're reading those directions. Now, I can also, on my calculator, go 5 times 5 times, and I can hit the pi button on the calculator, and I will get the same answer. Now, sometimes it might be like a tenth different, or even maybe out to the hundredth of a difference, just because here we're rounding it, and here the calculator is going way more digits. So on the calculator, the pi symbol is right here. Okay, so if I want to take 5 times 5, or 25, I can push times pi to get my answer, or I can go 25 pi, which if you see on there, you can see it's just 25 times pi, and you'll get the same answer. Okay, so most people find that button right there to be the easiest one to use rather than punching in 3.14. Down here I do the same thing. Depends on if you want to type in 3.14. So I could go 2 times 12.4 times 3.14. And I could go 2 times 12 times 12.4 times the pi button on the calculator. Okay, and this is one actually when you multiply it out, you get a little bit, a tenth of a difference. But I would accept either way, again, unless it specifically says which way to go. So just a little note about pi. On March 14th, March 14th is considered Pi Day because March is the third month, so that would be 3. And then the 14th would be 1/4, so 3.14. Happy Pi Day.